Hello students, welcome to my YouTube channel. In this video lecture, we are going to solve questions from 21 to 30 from Great Circle chapter in 𝐃𝐞𝐐𝐭 then math book. So let's start. Question number 21. The automatic flight control system in aircraft is coupled or connected to the guidance inputs from INS. Aircraft is flying between waypoints 55° north 20 west. Second waypoint is 55 north 30 west. What is the desired track selected on the CDU to the nearest whole degree? The initial track readout. That means we have to find basically great circle track at departure. Nothing else. So 55 north. So both positions are at 55 north. That means same latitude. 20 west, 30 west. 20 west, 30 west. So considering this is your north direction, north pole. So 20 west will be here, 30 will be to the west of it. And both are at 55 north. So the great circle track will be passing through the nearest north pole. A, B. Now, Rumline track at A will be 270. You're going from A to B following the straight track. It will be 270. Rumline track B to A will be reciprocal of 270, 090. Okay. Initial track readout from waypoint number 3. So waypoint number 3 is this 20° west longitude. So Rumline track is 270. Great circle track will be more than that. That is Rumline track this much plus another angle, plus additional convergency angle. So great circle track at A is Rumline track at A plus convergency angle. So 270 plus convergency angle. What is convergency here? Convergency is d long in degree into sine lat. What is the difference between the longitudes here? It's 10. What is the latitude? Sine 55. So sine 55 into 10 is 8 degree 11 minutes. Convergency angle will be half of that. 4 degree 5 minutes or approximately 4 degrees. So great circle will be 270 plus 4 degree, 274 degree. So great circle at A is 274 degrees. Okay. An aeroplane flying from A to B with a task of 480 knots. Autopilot is engaged and coupled with INS in which track AB is active. What is the track? What is the great circle track basically? So again similar question. We are in the south hemisphere. So the great circle will be like this. A, B, A59 south, 142 west. 61 south, 148 west. Right? So true airspeed is 480 knots. Okay, true airspeed is 480 knots. Now, do one more thing. Join this. So this is latitude 59 south. This latitude is 61 south. And this is 59 south, correct? So now we have a triangle here. This triangle. Okay. We have a triangle, which is this triangle. Fine. So let's find out. Let's find out this distance between this longitude and that longitude. That will be your line distance. Line distance equals to d long in minutes into cos lat. So d log 148, 142 is 6 degree into 60 cos 59. So that is 185 nautical miles. Great circle distance will be d lat 59 south, 61 south. That is 2 degree into 60. That is 120 nautical miles. So we have this side of the triangle 185 miles, that side 120. So tan theta, let's apply tan formula. This tan theta will be equal to opposite 185, correction 120 divided by adjacent 185. So 120 divided by 185 is 0.64. So theta will be inverse, tan inverse 0.648 something. So that is equal to 33 degrees, approximately 33 degrees. Okay, so this is 33. Now we know that this particular angle up to this point is 270. A to B is 270. So what will be the measurement of the angle from A से लेके यहाँ तक up to this point? It will be called Rumline track at A 270. This 270 minus this theta value, which is 33. So 270 minus 33 is 237. Now what will be the great circle track at A? Great circle track at A will be Rumline track at A up to this point minus this convergency angle. So what is convergency angle here? Find out convergency. Convergency is d long 6 degree sin lat. What is the latitude? 59 south and 61 south. So the mean is 60. So sin 60 into 6, that is 5 degree 11 minutes. Convergency angle will be half of that, 2 degree 35 minutes, or approximately 2 degree. So great circle at A will be Rumline at A minus convergency angle. So 237 minus 2 degree is 235 degrees. So this is the answer. Tricky sum, a tricky question, but if you apply the basics, you draw, you know the basics of direction, orientation, bearing, you will be able to navigate this question elegantly. So next, 23. Which pair of latitudes will produce a difference that is maximum? So the difference between the initial great circle track and the average great circle track. So initial great circle track and average great circle track. Average great circle track is nothing but your line. So basically we have to find the latitudes, the pair of latitudes where we are going to get the maximum difference, maximum convergence angle between a great circle track and a line track. Okay. So we all know that convergency angle is half of convergency. So half is constant, ignore that. What is convergency? D long in degree into sine of latitude. That means the difference that we have been asked to find out, the convergency angle difference, is directly proportional to sine of latitude. Correct? So let's check this latitudes one by one and see which pair produces the maximum difference. 60 north, 60 north. Okay? 60 north to 60 north. 60 north to 50 north. So here convergency will be d long is 10 degree multiplied by sine latitude, sine 60. So sine 60 into 10, 8.6, 60 north and 50 north. So 10 degree into sine of mean. 60 and 50 ka mean is 55. So sine 55 into 10, 8.1. 30 south, 30 north. Different hemispheres, not possible. 30 south and 25 south. 10 into sine of 27.5. 4.6. So the maximum. So the greatest number here is 8.6. So option A will be the correct answer. 24. Positions are given. What is the rhumb line bearing from A to B if great circle A to B is 100? So draw this. Okay. So great circle A to B. This is your great circle. A to B 100. So rhumb line A to B will be what? Rhumb line A to B will be great circle at A plus convergency angle. Convergency angle. So what is convergency here? D long 10 degree sine of latitude. We have two different latitudes, 55 north and 54 north. So the mean is sine of 54.5. So sine 54.5 into 10 is 8 degree 8 minutes. Half of that is 4 degree 4 minutes or approximately 4 degree. So your rhumb line track at A will be great circle track plus convergency angle, that is 104 degrees. Okay, simple. Next, you are flying from 60 degrees south, 70 west, 60 degrees south, 80 west. Initial track at departure is, comparing the initial track at departure and final track at destination, the difference between them is what? Okay, so the difference between initial great circle track and final great circle track is equal to convergency. So we have to find convergency here, value of convergency, which is d long in degrees into sine of latitude. So d long 70 west, 80 west, 10 degrees, latitude 60, 60, sine 60. 8 degree 39 minutes is your convergence. So the difference between the initial track and final track will be equal to 8 degree 39 minutes. Now you are traveling from, you are in the south hemisphere. So DIID diagram says, if you are in the south hemisphere and you are traveling in the westerly direction, the great circle track increases, right? So we are traveling from 60 south, 70 west से लेके 60 south, 80 west. So we are traveling from 60 south, 70 west, 60 south, 80 west. So we are traveling in the westerly direction. So what will happen? Increase. So So the initial great circle track, so the final great circle track at B will be more than great circle track at A by a value of 8 degree 39 minutes. Next, aircraft travels from A to B. Coordinates of A and B are given. What is the course of aircraft on its arrival at B at destination great circle track at Bravo? So let's draw this 45 south, 10 west, 30 west. So let's find convergency. D log 10 degree, sine latitude sine 45. So sine 45 into 10, 7 degree 4 minutes or approximately 7 degree. So convergency angle will be 3.5 degrees. 3.5, 3.5. Now, Rumline track B to A will be equal to 2. So we will find Rumline track A to B because we have to find destination. So Rumline track A to B, 270, right? Great circle track A to B is this much. So that will be equal to Rumline track A to B, this big value, minus this small value convergency angle. So Rumline track A to B minus convergency angle. So 270 minus 3 degree, let's say 3 degree. So 267. Now we have to find great circle at destination. So you start from here. What will be the great circle when you reach your destination? So great circle at B will be equal to great circle at A plus convergency. Why? The difference between two great circle tracks is equal to convergency. Now here you are traveling, you are in the south hemisphere and you are traveling in the westerly direction. So when you are in the south hemisphere, you travel westerly, the great circle change increases. Okay, so that's why we have added 267 plus 7 is 274 degrees. So great circle at arrival of B will be equal to 274 degrees. 27, three waypoints are given. What is the system? You are traveling from first waypoint to the second to the third. What is the track change when you are passing waypoint number 2? So waypoint 1 is 60 north, all three waypoints. Thirty west, 20 west. So now convergency angle will be equal to half of convergency. What is convergency here? B long 10 degree into sine lat sine 60. So that is equal to half of sine 60 into 10. That is 8 degree 39 minutes. So divide by 2, 4 degree 19 minutes or approximately 4 degrees. So convergency angle is 4 degree. Now Rumline track A to B is 090. It is 0, 9, 0. Rumline. So therefore, great circle track A to B will be rumline track minus convergency angle. This is your great circle. So 0, 9, 0 minus 4, 0, 8, 6. 0, 8, 6. Next, what will be the great circle track at B? Now the difference between two great circle tracks is equal to convergency. Is equal to convergency, right? So you are in the north hemisphere and you are traveling easterly direction. Okay, so when you are in the north hemisphere and you travel in the easterly direction, great circle track increases I. So great circle track at B will be equal to great circle track at A plus convergency. So 0.86 plus convergency is 8 degree or 9 degree. So 0.95 degree. So great circle track at B will be 0.95 degrees. Now great circle track at C. If great circle track at B is 0.95, what will be the great circle track at C? It will be equal to great circle track at B plus convergency. So 0.95 plus convergency 9 degree, that is equal to 104 degree. So now pay attention. In the beginning great circle track was 0.86. In the end it has become 104. At Bravo it is 0.95. It is 0.95. So the change, they have asked us to find the change in track when passing waypoint 2. So the change in track when passing waypoint 2 is equal to what? 104 minus 95. That is equal to 104 minus 95 is 9 degree. Okay. So while you are going from A to B, at point B there will be a change of 9 degree. There will be a change of 9 degrees. Okay. Minus 9 degree because great circle at B is less than great circle at C. So minus 9 degree. So this is your answer. What is a rhumb line? The vertex of a conformal polydoptic projection, maybe it's a printing error. The shortest distance between any 2 points, a straight line on a Lambert's chart, line on the earth which cuts all meridians at the same angle. So rhumb line by definition is a line on the surface of the earth which cuts all meridians at same angle. So let's say this is your earth surface. These are your longitudes. Okay. These are your latitudes. So all latitudes are your rhumb lines. They run east and west fixed direction and they will cut all longitudes or meridians at same angle. Okay. So lines on the earth which cuts all meridians at same angle is your rhumb line. The shortest distance between any 2 points on the earth's surface is given by or is a byproduct of a great circle track. A straight line on a Lambert's chart for short distances is equal to great circle. So by eliminating other options, uh, we are left with option D. So delta. Waypoint 1 and 2 are given. What will be the approximate latitude shown on the display when you pass 25° west? So we have done this question many times. So just start doing it. 60 south. Now we are in the south hemisphere. Okay, so my bad, I didn't read the question carefully. So you're traveling from 60 south, 30 west, 60 south, 20 west. Concept will remain the same, nothing will change, but the great circle will pass like this. So 60 south, 30 west, 20 west, 25 west, this longitude. Now draw a triangle, let's draw it like this. This total distance will be departure. So this will be half of departure. This will be equal to half of convergency angle, because this whole is convergency angle. This side of the triangle bisects that convergency angle into two equal parts, this one and this one. We have to find this particular latitude. We know this latitude is 60 south, so this latitude will be more than 60 south, going south direction. Now departure is, or upline distance is, d long in minutes into cos of lat. The video. So d long 10 degree into 60 minutes into cos 60. That is 300. So half of that will be 150 nautical miles. So this half departure is 150 miles. Convergency is 10 degree into sine latitude. That is 8 degree 39 minutes. Convergency angle will be half of that, 4 degree 19 minutes, or approximately 4 degree. Now let's apply tan theta. Tan of 4 degree is opposite side, which is this great circle track or great circle distance, divided by adjacent, which is 150 miles. So great circle distance will be 150 tan 4 into 150, 10.48 nautical, approximately, approximately 10.5 nautical, 10 point 10.5 nautical miles. Now we all know that 1 minute of latitude equals to 1 nautical mile. So 10.5 nautical mile or 10 nautical mile will be equal to approximately 10-minute latitude. Okay. So this is 60 degree south latitude. This will be 60 degree, 60 degree 5 minutes, correction, 60 degree 10 minutes south latitude. 10 minutes south latitude. In order to fly from A to B, maintaining a constant true course, okay, it is necessary to fly a rumline track. You want to fly from 10-degree north to 30-degree north between these two positions, and you want to maintain a constant true course, a constant angle. So you will have to fly a rumline track. By definition, rumline is a track that gives you constant direction. So that is the answer. So this concludes our lecture. I hope you have understood all the points that I have talked about in this video lecture, the solutions I provided. I hope you have understood them. You have learned something new today. Do hit the like button if you have liked this video lecture. Share this video with your friends and subscribe if you haven't yet. In my next video lecture, I will solve the next 10 questions. So let's meet there.